languages in the job market these days as well, and try to highlight those. And then we'll move on to some very quick, simple coding examples in Python. So I'll say let's just get on with it. So, starting off, what is Python? Just a bit of a background. You don't need to bother too much about it if any of this stuff doesn't make much sense to you, because this is coming from a computer science background. I've got a link down here which you can visit to actually explore a bit more about it. And Python is one of the most talked about languages on the internet these days. So, anything that you hear about which you would like to learn a bit more about, just simply Google it and you'll see tons of articles and examples and exercises about it. So yeah, you can't go wrong with that. So what is Python? It's a general purpose programming language that is often applied in scripting roles. So this term scripting here, we'll try to sort of highlight that a bit. And scripting is one of the strengths of Python and as well as a weakness of Python, and we'll see how that works. It's a programming language as well as a scripting language. So you should be able to distinguish between these two terms. What's a programming language and how does it differ from a scripting language? Python is actually both. What we mainly use it as a scripting language. Scripting language is also an interpreted language. So the difference between a program and a script, or a programming language and a scripting language, is very briefly mentioned here. When you write a program like in one of the traditional programming languages like C++ or something like that, that program is executed on your computer hardware. That is, the source is first compiled and the results of that compilation is expected. Like you compile the source, and if there are no errors in the program, it would produce some results, and that those results are the output of your program. A program in general is a sequence of instructions. Any computer software, any program is simply a sequence of instructions, one after another, and we'll see a few examples of those in a bit, written so that a computer can perform certain tasks. That's straightforward, doesn't need any explanation. You give it a sequence of instructions and it'll just perform those instructions. And if those instructions were given in a proper manner, then you should be able to see some expected output coming out of the other end. So this is basically what a program does. However, a script does not execute directly on the hardware. So a script is not executed, it is rather interpreted. So that means um, between a scripting language and your computer hardwares, there's an intermediary sitting in there, which is called an interpreter. Interpreter is responsible for taking your script and executing it on the machine. So a script is a code written in a scripting language. So when you write the code in Python, you can call that program. People use these terms interchangeably. But just to have a clear idea in your mind, and we'll see in a bit, why is this a limitation as well as a strength of Python. A scripting language is nothing but a type of programming language in which we can write code. In Python, it's called the bytecode. I mean, the interpreter creates the bytecode in Python to control another software application. So Python will not interact with your computer hardware directly. It will, in turn, interact with another application which will run on your computer hardware. So this is a bit of a technical background. I mean, just so you can appreciate the difference between a program and a script, there's a very good link here on medium.com. You can go have a quick look at it, and that has given you some very quick examples with how Java does it, how C++ does it, and how Python does it. So it's a, sorry. Let me just open it up for you. So difference between a compiler, an interpreter with respect to a Java virtual machine, which is suitable for Java, and a Python virtual machine. This is how Python works. So it's quite a detailed article. Have a look through it. It's explained quite well in detail. However, this is outside the scope of our webinar today, because we will be otherwise involved in an unnecessary or complicated discussion. This is really up to you. If you want to go deeper into it, it's all there. If this makes you happy and you're good to go forward, then that's fine. We can simply move forward. So Python in general is a scripting language. That's the takeaway from this slide. A bit of history of Python. It was invented in Netherlands. So it's a good idea to know who built it, how long has it been around, and all that kind of stuff. Invented in Netherlands, early 90s by Guido van Rossum, or however, I mean, if you can pronounce it right, that's great, but Guido van Rossum, that's what I'll call it. It was conceived in late 80s and its implementation was started in December 1989. So Python has been around for good 30 years. I mean, it's just recently in last 5 or 6 years with the advent of machine learning, it became so popular that machine learning is now becoming synonymous with Python. Like if you want to learn machine learning, predictive analytics, then Python is the way to go forward. It's only compared with R these days. R is another very famous programming language, and R has been used by statisticians for last 30 or 40 years. R is quite an old programming language as well. But R does have limitations. I mean, once again, that's a technical discussion, but Python beats all of those limitations. You would probably see a lot of people still using R and still preferring R because they've been using R for 30, 35 years or something like that. So asking someone to just move on to a new platform just because it works. So you'll see a lot of debate, a lot of bias between whether to use R, whether to use Python. But the fact remains, if you don't know any of these languages, and if you're just taking your first steps to learn one of these languages, then Python is the way to go forward. If you had some experience in R and you want to move ahead with R, that's perfectly fine. But Python is basically a one-stop shop for all the analytical needs. Uh, right, just someone just put a line there. I don't know how to get rid of it. I don't know what that means anyway. Hopefully that'll go away. Uh, where does this come from? It came from the name Python. It's not coming from the Python as in the snake Python. There used to be a comedy series in 70s which was aired in UK and all over Europe. It was called Monty Python's Flying Circus. Those who are I mean, those who were around in like 70s and 80s in Pakistan, you must have seen this television show called 50/50 that was a ripoff of Monty Python's Flying Circus. It's all available on internet, on YouTube. Really funny stuff. If you're really into that kind of stuff, you'll love this. So Monty Python's Flying Circus, have a look at that. So the Python actually came from Monty Python's Flying Circus. It's not coming from a snake or anything like that. Python is open source from beginning, like no one has to pay nothing for Python. Like Python is developed through a community, and there are thousands of developers, or maybe tens of thousands of developers all over the world who are constantly writing new libraries for Python, adding to the repository of library which Python already contains in all of the different domains that Python is used: analytical domain and web development and server development and application development. So it's constantly being added, and it's added with the context of Python being an open source software, as in whatever you see in Python, whatever works in Python is totally free. You don't have to download it from torrents. You don't have to run any stolen serial keys or anything like that. You download it, you run it, and it's perfectly fine. It's a high-level language with an easy-to-understand syntax. So we go back to that scripting aspect that we talked about. The reason that Python is a scripting language makes Python very easy to understand for beginners. When we talk about this high level and low level, this level of a language signifies when you're programming in that language, how close you are to the machine executable code. If you think about like old programming languages, something in early days like assembly language or assembler language, this is basically giving instructions to machine in a form that machine can understand. So the distance between machine and the man is very much reduced. You have to go all the way down to the microprocessor level and give it instructions that electronic circuitry can understand. So you need really high-end skills for that. So not everyone can program in that. So as we move on up from that area, like you have to give machine executable code all the way up to Python, that means you'll see that in a bit, those Python instructions that you write down are much closer to human language than machine language. So the level of a language is basically can be, I mean, in simplest of terms, it can be understood whether it is close to how machines understand computation versus how human understands computation. So if I'm writing code in a language which makes logical sense to me. They're simple mathematical equations, which make sense to me. There are statements like print, input, output, and that makes sense to me. Input means we're taking something in, output means we're giving something out, print means we're trying to print something. So using these simple English phrases, English terms, and so on, and the logical approach towards it, once you look at the code, it makes sense to you. But once you look at, like one of the languages I mentioned, assembly language code, I mean, you have to be an expert to understand how things are working in that. So that is a strength of Python. It's very easy to type. It's very easy to get into. The syntax is very easy because it's a scripting language. There's an interpreter in between that takes simpler commands from you and then converts them into some sort of a code that machine can execute. But that also becomes a limitation of Python because that means Python is not as computationally efficient as, let's say, C++, because C++ is at a much lower level than Python and it can execute its code in a much more efficient way than Python does. So think about it. Python is ideally suited and ideally used for analytical purposes, but you won't see many software developers developing commercial applications using Python because the performance of Python for those applications would be much less than an application developed in Java or an application developed in C++. We talked about this library, NumPy, last time around. Now, NumPy is basically giving superpowers to Python because NumPy is written in C++. So that means when you're coding with NumPy library, you may be coding in simple Python, but behind the scenes, it's getting executed directly with C++ libraries, and you get all the C++, all the good stuff from C++ integrated into Python. And then we also talked about all the other analytical libraries like SciPy and Pandas and Matplotlib visualization. They're all built on top of NumPy. So that means they can enjoy those fast speeds as well. And then there are C ports, C++ ports for Python. There's a version of Python called Cython, that's C with Python, Cython, and so on. So there's a lot happening within this domain. It's a good idea to have a basic understanding of it because then at some stages, if you're running large experiments, they can become really, really computationally expensive. And you need to have a clear idea about how you can boost up the performance of your algorithm or boost up the training time of your algorithm. And in that case, you need to sort of dig a bit deeper into how that code in Python is being executed. But for simpler experiments, like which run on a single computer, on a single hard disk, on a single processor, you don't need to worry too much about that. But once again, it's a good idea to have all of that in mind. Scope of Python, it's pretty much used in all of those the key scientific areas that we talked about these days. Primarily, it's used for scientific modeling, analysis of data, and this is basically our main focus today. Bioinformatics, system administration, Unix, web logic, web application development, computer graphics. Jython, I talked about. Cython is a port for Python, port of Python for C programming language. Java, I mean, when you put Python with Java, there's a port for that called Jython. I mean, that's for developers. You don't need to worry too much about it. Just to highlight the scope of Python, that's it's being used everywhere for all the different purposes. And here are some of the key applications, all the way from image processing. You see all the image processing and facial recognition and self-driving cars and all of that stuff, which is basically fueled by image processing capabilities. Web applications, web servers, websites are built and delivered with Python. Desktop applications, normally stuff you run in Windows. Console-based applications, software development, scientific and numeric, and this is your area of focus really for researchers, for analysts. Scientific and numeric computation is what you're interested in. You can develop business applications, audio or video applications, 3D, CAD, drawing applications, and complete enterprise-wide applications. So Python basically works everywhere. So Python these days, that's why, and I'll show you a few graphs in a bit, it is one of the most demanded languages in the world out there. So whatever you learn with Python, you can't go wrong with that. You can easily move from one area, like you may be doing some scientific and numeric computing today as a part of your research project that you may be doing. But the skills that you learn at this stage, some of them or most of them can be easily ported to towards software development. Maybe you've learned, because we talked about that gap between research and deployment, and we talked about the fact that existing tools, the proprietary tools, don't allow you to develop or deploy that model that you've developed. But Python takes away those limitations. You build a model in Python, you develop a software within Python. If that software works, if everything is fine, you can take that to an enterprise application system written in Python. So the skills that you learn in Python go a very long way, right? So that is another what you want to call it, another reason why people must adopt Python rather than R or any other program. You can't do this stuff in R. R is purely scientific and numeric, so it'll help you run all the statistical tests, it'll help you run all the evaluations on those tests, but you can't think about, let's say, developing enterprise applications. I mean, if you push it, you might be able to come up with something, but it won't be ideal. It is not the state of the art solution for that. So scope of Python is very huge. It's pretty much in all of the areas that we talk about, all of the scientific areas that we talk about. Right. Doctor, can you tell me how to get rid of this line? How did it come there? Sorry. There's a yellow line that's a bit of a... Right. Can anyone give me an idea? How do I get rid of this
Yes,
line?
there is an option like you should block the annotation.
Okay. Annotate, and
Block annotators.
I'm clearing it, but it's not doing anything. So I
There
see
is
a...
an there is an option of eraser as well. Like you can
All
erase
right, I
this
got it.
particular
I
line.
got it. Okay, so how do I block it? Okay, I don't see much blocking there, but let's say hopefully this doesn't happen again. So we're good. Cool. All right, moving on. So why do people use Python? We saw some of the reasons. Python is object oriented. That's once again something related to computer science. Object oriented is, I mean, in simplest of terms, without going into any technical details, is object oriented approach versus the structured approach, which existed before object. These days, pretty much all programming languages are object oriented, and those languages which are not object oriented have become obsolete. Like, I'm sure you've heard about languages that were around 20, 30 years ago, like COBOL and Pascal and so on. Those languages were not object oriented, so they have become obsolete now. No one uses them. They have serious limitations. Object oriented languages allow you to write code which is maintainable, which is reusable. So, in essence, what it allows you is to write more efficient code, which can be highly reusable, and you can develop really sophisticated applications with a minimal amount of code. And that code is upgradable, reusable in such a way. So, when you write a code, when you write a program, and if someone has to make some changes to it, they won't have to do it from scratch. Basically, they can just modify the objects that you've created. That is an advanced topic in programming language. Once you study about the basics of Python, then you move on towards the object-oriented approach. And once you've done your analysis, you don't need to create objects for your analysis. But once you want to take your analysis into production, then you might want to write your code or rewrite your code in a more efficient manner. And object orientation is that approach. And Python allows you to do that. Python allows indentation within the code, and we will see an example of that, which makes code really easy to write and really easy and nice and clean to read and so on. Python is free, open source, that goes without saying. R is free, R is open source as well. But another language which is quite heavily used in academia for analysis is MATLAB. Now, MATLAB is not free, MATLAB is really expensive. And all the applications or any output of the MATLAB, if you want to commercialize it, if you want to make some money out of it, you have to actually pay MATLAB. So MATLAB MathWorks, the company that makes MATLAB, is called MathWorks. MathWorks basically expect a certain amount of certain proportion of money when you're making any money through the applications that you developed in MATLAB. So not a very good option. However, it is very heavily used within research purpose for electrical engineering, for computer science, and so on. But Python is open source, Python is free. You don't need to worry about paying anything ever, ever. There are some of the coding related benefits of Python, some of the features of Python, and once again, they're best explained through demonstration. So just have a quick look at these, and once we get in there, I'll try to explain most of these, and you'll see these in practice. It allows dynamic typing. On the next slide, I'll show you what is that and why does it matter. It has all the built-in types and tools. It has a lot of library utilities. It has tons of third-party utilities, NumPy, SciPy. We talked about those, and all the other areas that we talked about. In each one of those areas, Python has a good bunch of libraries that help you and get along with that. It has automatic memory management, so you don't need to worry about too much about how the memory is being used within the computer. So it just makes you focus on your experiment, not what's happening in the background. Of course, it gives you an opportunity, like if you're a computer science savvy and if you want to see what's happening on the hardware level, you can by all means do that. But if that's not your piece of cake, then you can simply forget about it and keep coding in Python. The portability of Python runs virtually in every major platform used today. I mean, you can have a Python IDE on your mobile phones as well, on your Android and then on your iOS. So you can be writing Python code on the move. So it virtually runs on every major platform because it has an interpreter that comes with the Python. It'll convert whatever code you're writing to the respective machine. As long as you have a compatible Python interpreter installed, Python programs will run in exactly the same manner, irrespective of the platform, right? So, I mean, you write a code on your Windows machine, then you take it onto a Linux machine, a Mac machine, move it to your mobile phone or any other devices. There are thousands of different types of computing devices out there. Python code, you should be able to run it on all of them. So think about smart watches and everything that they're coming out these days. If you want to ever develop some models or applications for those watches, I mean, you can't go wrong with Python. On top of everything, I mean, I've written it at the bottom, but that's the first reason why people use Python. It's very easy to learn. I mean, it's one of the easiest. I mean, I won't even say one of the easiest. It's the easiest language out there to learn with such a potential. I mean, you may find an easier language, but that's just for teaching kids how to code. It won't have any more potential than that. But Python, it's easy to learn and it goes all the way. So that's the key. And these are all the computer science related benefits. If you dig deeper, you'll have much more understanding of these. But if you don't want to bother too much about any of this at this stage, that's perfectly fine. Just focus on this. It's the easiest thing to learn out there. Okay, so dynamic typing, that's the key difference. That's the difference what makes Python so easy to understand and so easy to code as compared to other programming language. The key is dynamic typing. Uh, Java is statically typed. Variables are declared to refer to objects. So, I mean, this could be a bit confusing for you. Let me show you a few examples first, and then you can fully appreciate that. So these are a couple of examples of a code written in Java and the same code written in Python. And you can see, first of all, the number of lines of codes that you're writing in Python. In Python, you could do something. I mean, this is a single line. It's just split over here, but it's the same line. So what you do in 18, almost 18, or at least 15 lines of code in Java, you can do it in 3 lines in Python. And you can see the complexity of this code. Now, in order to write that, now what's happening here is we're simply opening a file called test.txt, some sort of a text file. Um, we're reading and printing the contents of that file. So you read the file, print the contents, and then you close the file. That's it. And you have to do the same thing in Java. This is the sort of code you have to write. So you can see there are so many conventions, and if any of those are not fully met, you'll see tons of errors coming out of this. So, I mean, I really don't want you to take you through it, but think about it. Think about all of these brackets. These brackets must be presented in a certain way. Here, we used a simple variable called myFile to load the data from a file. And we didn't define this variable. We dynamically typed. Dynamic typing means you can just define a variable when you need it. But here, you should be able to see that you have to define a variable called a line. This is reading one line of the file. It has to be a string type of variable. String means a text variable. You define it, you initialize it, you set it equal to null. And then while there are lines existing within that file that you're trying to read, you're loading in one file at a time within this variable. And then you're doing some fancy formatting on that variable and printing one line at a time. And this makes this process really, really complex. If you just want to read and print the contents of the file, Python does it very naturally. You open the file, you print the file, and you close the file. I mean, all you have to remember are these three methods. Open methods takes in a directory address, a file structure address, and opens that file. Print command will actually read the content of file and then print it. And once you've printed it, you would like to close that file, you close it just like you're closing it here. So you can see it's very intuitive. It makes sense. I mean, you can't go wrong with this. You open something, you print something, you close something, right? I mean, it won't get any simpler than that. But all the other formalities that you see over here that come with Java, I mean, you need at least two or three courses, a couple of courses in Java to start programming. In Java, the level of programming analysis requires, but with Python, you could just do it with a few days of training. Here's another one. Sorry. This is basically creating a list, an empty list. I'll show it to you in Python first. Appending some characters to it. So appending the first character to the list as the first element is A, the second element is B, and the third element is C. And you print the list, and hopefully, I mean, I haven't shown the output. We can do that towards the code. It'll print a list with three elements in it, the ones we have supplied A, B, and C. So once again, very intuitive. Create an empty list because we don't know what's going to go in there. So we create an empty list and then we simply keep appending. So all you have to remember there is append. Append and keep appending whatever you want to keep. And once again, the good old fashioned the print command will print whatever you've done. But if you want to do the same thing in Java, you have to import certain things, array list, you have to define classes. We talked about object orientation. Everything in Python is an object, but you don't have to define these objects because Python creates objects out of the box. But over here, you're defining classes, you're defining how those classes would act, what you can and cannot do with those classes. And then you're defining those variables, a new array list, and then you're adding stuff to it and think about all of these. I mean, once you start coding in Python, the first sort of errors that you come across is you forget to put these brackets on the right place. You forget to put these semicolons at the right place, and you see tons of error. Everything must be terminated with a semicolon. However, you can see Python does not go for any of those conventions. It keeps the whole thing simple. And this is basically all to do with dynamic typing. The key difference between this code and this code, which are doing exactly the same thing, and this code and that code, which are doing exactly the same thing, is dynamic typing. Uh, Right. So I think once again, if anyone wants to dig a bit deeper into it, just try to read a good article on Medium or something about it. That'll help you truly appreciate the ease of use of Python. So the key here is the ease of use, and the dynamic typing approach of Python basically highlights that. So that's all good, but who's using Python? I mean, if I learn Python, is that in line with what the industry is using out there? So that's a very valid question, because if you want to learn a tool, then you want to be sure that once you go out in the job market with those skills in your hand, that is something which will be accepted in the job market. So who uses Python? Pretty much everyone uses Python these days. So you can see I mean, I'll search around these big names. Um, Python is being applied in real revenue generating products by real companies. So it's not something like a software running on your computer, which helps you calculate a certain p-value and that's it. The role of that software is done. You can't take it forward. With Python, you can go all the way. So all of these names, Facebook is using Python, YouTube, Google, Mozilla, Quora, Spotify, NASA is using Python. So there you go. Google makes extensive use of Python in its web search system. So Google's web search is every time you Google something, it's some Python running in the background. And the guy who created Python is Google's employee. So that tells you a lot about Python. Intel, Cisco, HP, Seagate, Qualcomm, all of these big companies, as well as IBM, use Python for hardware testing. S3, which use, I'm not sure if you've heard about this software, it's a state of the art geo visualization software called ArcGIS. So, all the fancy visualization sort of stuff that you see in Google Earth. If you want to create it on your own, then you use ArcGIS. And all the customization and user customization in ArcGIS is through Python. YouTube sharing video service is all written, mainly written in Python. And there are a lot of examples, and you can search on internet. So just to highlight the idea that it's not just a introductory programming language, and then once you're familiar with it, you'll have to move somewhere else to learn a much more practical language to productionize whatever you've done. Python will take you all of the way. So, last slide. Once again, highlighting Python versus other programming platform. Indeed.com is one of the, I think, best job search websites. I mean, LinkedIn, Indeed.com, and MonsterJobs.com. I mean, these uh, companies help thousands of people get on jobs, technical jobs, and all sorts of jobs. So this is basically just some data gathered from Indeed.com in terms of what kind of analytical tools employers are demanding. So looking at that, SQL is on the top because SQL is not really a programming language as such. SQL is a language. It's more like a logical language to connect to databases, relational databases, and to be able to pull data out of those databases and do some initial data cleaning or something like that, maybe. So the idea, I mean, in my intuition, why this is above Python is um, for last 40 or 50 years, since 1970s and so on, all the major databases have been developed using some sort of a relational database management system, and all the data for organizations who've been operating for quite some time now exists in some sort of an SQL database. And in order to run any analysis, any experiment like that, before you move on with Python or R or any other language, you need the data. So SQL is more important than Python because if you don't have the data, if you don't know SQL to pull the data from the databases, you can't do much with Python or any other language for that matter, really. So counting out SQL, because it's not an analytical language. I mean, you can do basic analysis in SQL, but it only goes a certain way. You can't really push it all the way to machine learning or something like that, unless there are custom ports for SQL. I mean, SQL, traditional SQL, is for data extraction, data aggregation, data summarization, pivot tables, and all those kind of things where you maneuver the shape of the data. And that's where Python is. After Python, it goes for Java, Hadoop, C, R exists down there, SAS, you must have heard about it, Tableau, Scala, MATLAB, and that's your SPSS. This is what researchers use. If you get a similar list, which is comparing all the different analytical platforms, with respect to how many papers are being published in research journals all over the world, then I can tell you SPSS will be probably somewhere on the top because SPS is the favorite language for publishing papers. But like we talked about it last time, it just stops there. And that's why um, for journals, I mean, journals, they just want to see your results, whether they're statistically significant or not. They really don't care too much about which tools you've used. But if you think about an employer from a job market point of view, they do care because if you know tools which can be used for production, then they would prefer you. If you can do some analysis in SPSS, then your skills in terms of production, in terms of analysis or inferential statistics that we talked about last time, you may be well suited to, my SPSS may be well suited for you to actually conduct your experiments. But if you want to productionize them, then you can see Python, Java, C, R, they go way on top. So this is the adoption rate. And I mean, just to help you develop a strong intuition around this, that why you need to do this. Right, the Python environment. Now, how do you run Python on your software, on your computer, Python software on your computer? So let's just quickly have a look at. I think Dr. Sajid shared a link with you. I'm not really sure if everyone has downloaded it, but if you want to run Python on your system, you need something called Anaconda Navigator. and I'll just put download there. So you go to products, individual edition, download, and it'll take you to the download area. So this is basically what you need to do. I'm sure all of you, most of you would be on a Windows, and you'll be on a latest version of Windows most of the time, but you do need to check that. Windows 10 64-bit edition, I believe most of you would go for something like this. But
Your
if
screen
someone
is
just,
not shared. Your screen is not shared,
all
so
right,
go
sorry, I
ahead.
was sharing a
Yeah.
different screen. Hang on, let me just stop the share first. And share my screen again. I'm actually using two screens, that's why I am getting lost. So that is weird. Yeah, so every time I move from one screen to the other, I tend to lose stuff. That is strange. No, I don't see much happening there. So I'm not sharing screen right now, but if I click on share screen, I don't know if anyone can help me. I click on share screen and nothing is happening. Weird.
I think you can ask from the host. It will
What's
help.
up? Can you give me, because I'm clicking on share screen and I don't see those options to share screen for some reason. Sorry about this. I don't not know why this is happening.
नहीं ये सब मैंने तो जो उसकी थी ना परमिशन वो होती है वो मल्टीपल पार्टिसिपेंट कैन शेयर वो तो किया हुआ है आई थिंक देयर इज सम प्रॉब्लम एट योर एंड मे बी
Okay, let me just leave and come back in then, I think, because I don't see that screen sharing thing that appears on the top. It's gone for some reason. Let me just leave and join again.
Yeah, sometimes it may happen. It may happen. It also happened to me a few times.
Yeah, I
Yeah, you
think
can leave.
this is something
You
to do
leave.
with Zoom. I can't even leave the
Uh,
meeting anymore. I'm clicking on leave,
you
and
leave and then you join again.
let
It
me
should
just
be no
close
problem.
Zoom and just log back in again because I can't seem to do anything. The button's not working. So all right, so I'm back on, and let's see if I can share my screen now. So right now it seems to be working. So which screen am I sharing? Right, this one. Share. Okay, I got it. Right, so I was talking about the Anaconda environment. You need to go to anaconda.com. Let me, I believe you didn't see that. Go to anaconda.com. I mean, if you want to do it now or maybe just make a note of it, do it later because that software is about 400, about 500 megabytes. So if you're in a broadband, if you're a high speed connection, that shouldn't take long. But if your connection is a bit slower, then that might take a while. So anyway, just to keep a note of that, you go to anaconda.com. Let me just start from the beginning. Anaconda.com. Now, Anaconda is a complete Python development environment. It eases up the task of installing pandas with all the necessary libraries on your computer. Because if you don't go for Anaconda, there are other ways to do it. Traditional ways to do it would be install Python first, then install this on top of that, then install that on top of that. So all the libraries that we talked about previously, All of those libraries are there. Most of them are there already developed in Anaconda, already sort of compiled with Python in Anaconda. And you just need to install this one softwares and it'll make your computer ready for Python-based analysis without bothering about giving system paths and telling your system where Python is installed, where everything else is installed. So you go to anaconda.com, you go to products, you go to individual edition. That's your data science toolkit. Everything that you need is there. Click on download, and that will show you a few options there. If you're on a Mac, mostly Macs are all 64-bit. Linux is all 64-bit. So if you're using one of those computers, but I would assume that most of you are using Windows, so stick with this one. Latest edition of Windows, normally, unless you have a good reason to go for a 32-bit Windows, you'd be using a 64-bit. So you just download it, and once you download and install it, it won't even ask you for a restart or anything like that, but your system will be ready for Python programming. Let me just quickly show you the Anaconda prompt. Right, so that's your Anaconda. Screen, stop sharing. Right, so I think it's not a very good idea to run it on two screens. I thought that would actually help me do a better demonstration, but that's actually messing everything up on my computer. Uh, Give me 1 second with it. Right. Okay, this is getting a bit messy now. All right, so I think I'll. Right, so I think it's something to do with Zoom. It's not working so well on two screens, so I shouldn't really bother to mess too much with it. It's gone again, just like before. Right, so I lose all the view. I think you guys can see me, but I can't seem to be.
Sorry, we cannot hear you.
Yeah, I think it's Zoom playing tricks on my computer. I'd actually try to run it on two different screens, but Zoom is actually messing it all up. So I'll just try to keep it simple for now. Really try not to show you too many windows because that just gets lost. So the idea was download Anaconda, install Anaconda just like any other software that you would download and install on your computer. And once you have that installed, you'll get something called an Anaconda Navigator on your system. And that is what I was trying to show you, but as soon as I move towards that, I lose my zoom thing. That's weird. Oh. I think I'll leave that towards the end, what Anaconda looks like. Yeah, but when someone shared that, that looks good. But I'll just move on to the coding bit for now because I'd like to show you the code because that was the key stuff that I wanted to show you today. And then after that, I'll try to give it another go and try to yeah, so I'm viewing Shumaila's screen. This is what Anaconda looks like. She's got a lot of stuff installed on it, so that's a good thing. Um, if you could go to home, please. Yeah, it's best if I show you that way. Yeah, so this is what an Anaconda interface looks. I'm sure everyone can see that. This is what it looks like on my other screen, but I can't really show you that because as soon as I move it here, I lose my window. So once you download and install Anaconda Navigator and run it, this is the icon you'll see on your desktop. Once you run it, this is the default interface that you will see. And what you need to do is what we're using right now. These are all the different type of IDEs that you can use to write Python code, or even there's an R Studio there if you want to code in R, that's there as well. So that's all good. This is what you will see. What I'm doing right now is opening a Jupyter notebook. And in order to do that, all you have to do is click on the launch button and the launch will open a new notebook. So once that notebook is open, that's when I can show you what it looks like. If I do a local host. Right. So once you got the notebook open, it'll create a web server on your computer. You don't have to do anything about it. You just to click on Jupyter Notebook. It'll open a web server and it'll give you a default location. And this is where you'll save your scripts. So I've got my scripts saved down here and I've got them open already. So all you need to do is, for example, if I go to, if I want to save my scripts in the Python folder, I need to go create a new Python 3 script, and this is the interface that I get. Now, this is called a Jupyter Notebook. A Jupyter Notebook is an alternative way of coding in Jupyter, and it's a very good tool for teaching and learning purpose because you can see intermediate results. Otherwise, I mean, if you've seen program code or the example that I showed you earlier on written in Java and all the languages, it's all written in a single go. So the program executes from the top, goes all the way to the bottom, and you get to see the end results after the execution. But for analysis person, keep in mind that every time you manipulate the data, you bring in some changes to the data, you would like to see what's happening at every intermediate stage. So this allows you to, like, if I say 1 plus 1, 2. If I'll explain that to you. I put A equals 5, I put B equals 10, and then I want to calculate some result.
The screen
Excuse me,
is
sir. Your
static.
screen is not synchronizing with your wording.
Oh,
Is
I think
it's
it's delay then. I mean, if it's do you see the screen first or do you hear me first?
no, the notebook is not visible. Actually, it is in the Anaconda Navigator. You have opened the notebook, but still the notebook is not visible.
Oh man, that is some weird stuff happening here. Is it better now?
Yes, now
जी
it's
अब
visible.
ठीक है ना इट्स
Okay,
ओके
okay. I need to practice that on two screens. Sorry about all the confusion really, because I thought it'd be straightforward really. I'm just using two screens. So yeah, I mean, the idea is in a Jupyter Notebook, let me just get rid of these and do it again. So Jupyter Notebook allows you to run code in sequence of steps, and you can see the intermediate results. So if I do A equals 10, B equals 20, and C equals, I don't know, A times B. and then I print C. See, so you see a result there. Now I want to take it further. D equals C divided by 10. And then you print D. Now think about your real analysis that you'd be doing. Instead of writing 50 lines of code and seeing the output, there are ways to debug your program other way. But this is, and you'll see the notebooks that I've got created for you. What you can do with these Jupyter notebooks that you probably will find it hard to do otherwise is something like this. Now, I've created this notebook already for you. So I've put in some text, which I will explain, and I've left some parts for coding, which I will do as we go along. So this makes it a very rich teaching tool. So there is content in there, as well as we can throw code in there as well. So that's a Jupyter notebook. And initially it was just like a teaching and learning tool, but now these Jupyter notebooks can be mounted on Google Cloud and Amazon Web Services as it is. So it's not a teaching and learning tool anymore. It's great for teaching and learning, and whatever you develop in this Jupyter notebook can be taken into production straight away. So that makes it really useful. You can learn from it and you can take it to production at the same time. You won't have to rewrite your code and so on. So when we're talking about Python, I've got a couple of notebooks which I've got some details in, and I'll fill in some codes to actually show you how things are done in Python. Uh, so let's just start with it, and as we move along, I'll try to explain that. The first thing that you need to understand, I mean, with Python or any other programming language, is how different type of data is processed by that programming language. And the very basic type of data that you would like to process or you would start with are numbers in Python. How do you process numbers within Python? And good for us, processing numbers in Python is as easy as processing numbers in a calculator. So just like I'm sure everyone's used a calculator at some stage. So just like when you're using a calculator, you don't get to worry too much about where everything is coming from. You just do a multiplication or a division or anything like that. So in Python, integers are whole numbers, positive or negative. These are just like simple conventions. There's no need to explain them in detail. There are two types of numbers in Python. There are integers, which are referred to as int, but it is dynamic typing. So we talked about dynamic typing before. You don't have to define an integer. You can simply start using integers. Or a floating point number in Python are notable because they have a decimal point in them. So if you ever see a scientific notation, let me zoom in a bit. 3e power 2, which is 3 into 10 raised to power 2, scientific notation, that would be a floating point number. 2 into 10 raised to power 2, 1.2 minus 0.5. So if there's a decimal number or see a scientific notation, Python uses floating point numbers for it. And otherwise, for all the whole numbers, integers, positive or negative, it's simply integers. So you need to understand, because you won't have to define this. So if you define x as 1.2, Python will automatically make it a floating point number without asking you, because the dynamic typing comes into play for that. So let's see some basic arithmetic, how we do that in Python. So like I said, if we talk about addition, 1 plus 1 is 2. Right, so I type 1 plus 1. In order to execute that cell, I'll press Shift and Enter. Shift and Enter, execute that cell. If I want to add more cells, I can click on plus sign, or I can press A on my keyboard, and that will do the same thing. So that's your addition. That's your subtraction. That's your multiplication with an asterisk sign. Oh, sorry. And what happens is I've just changed. There are two types of cells within this Jupyter notebook. These cells are for writing code. These are called coding cells, and these are called markdown. So if I click on this, you'll see the markdown language, which has been used to, when I execute that, it becomes a heading and nice bullet points and everything. And you can change the cell from code type. So what I did was I accidentally changed this to a markdown type cell. So that means I can't execute it. It is seeing that as simply text. So I can go to cell type, and change it back to code. So that makes it a coding cell. and you see the results. And just like that, you can have floor division. I don't know, 12, 15 divided by 4, which is with a double slash, forward slash, which is 3. Floor division basically gives you the highest integer, which is equal to or less than the real answer. So 15 divided by 4, the answer would be 3 point something something, but at that point something something is taken off, and the highest integer value that it can provide you, it'll give you that. It can also do modular division. If I do 15's modulo, and we use a percentage sign for modulo, divide by, once again, let's say 4. Sorry. The answer is 3. Once again, let's just try a different example. If I do 20 modulo 3, the answer is 2. 20 modulo 3, it shouldn't be 2. 1 second. Let's do 7 modulo 4. That's weird. This is the remainder that you get. So you divide 7 by 4, and the remainder you get is 3. So 4 times 1 is 4, and the remainder is 3. So you get the remainders with a modulo sign. You get the ceiling value of a division through double forward slash. This is how you multiply. If you want to take power of something, it's a good idea. I mean, just to highlight how it's done, you can use a hash sign to make comments within the cell. So let's call this an addition, because when we look back at this, it'll make much more sense. So this is addition. Keep in mind, whatever you write after a hash sign does not get executed. It's just some comments. These are called comments, and you make comments in Python using a hash sign. So this was a subtraction. So think of it as a lesson in how to use these Jupyter notebooks and how to type code. This was a multiplication. Right, this might take a while if I keep typing in all the comments, but let me just do for a few beginning one. That was a ceiling, and this was a modulo or remainder. Right, so just like that, you can take powers of numbers. And power simply uses double asterisk instead of 1. So if you want to take 2, in some other programming languages, you may write 2 raised to power 3 like that, but in Python, you use double asterisk, so which means 2 raised to power 3. And if I execute it, you get 8. And just like that, following the same idea, if you want to take square roots, there are built-in functions for square roots as well. But if you want to take a square root of any number, if you want to take the square root of 4, we can simply take 4 raised to power 0.5, which is the same as taking the square root of 4. So what I'm trying to highlight here is, once you get into Python and start using some basic arithmetic, all you need to do is simply use your calculator approach. If you know how to do numbers in calculators, you should do exactly the same in Python. And this is once again because of dynamic typing, because you don't have to define that this is an integer type and this is some other type, and you don't have to define types. You don't have to define any other sort of formalities that all the traditional programming languages bring. So arithmetic is as simple as it can get. Also, you can keep an eye on a couple of other things. Sorry, just below this. If you want to, let's say, focus on order of operations, right? That is once again basic maths. If you do a 2 plus, we can put spaces there to make it clean, 2 plus 10 multiplied by 10, maybe plus 3. So we know from basic arithmetic that 10 gets multiplied with 10 first. and then either 3 or 2 gets added, and then the other one gets added. So multiplication comes before addition, and parentheses come before multiplication and division. So all of that stuff, I'm sure you do that. So the answer becomes 105 and so on. And you can also use parentheses in those equations as well. So 2 plus 10. This is very simple arithmetic, and some of you might be wondering why we're doing this, because later on when you're writing your model formulas, you'll use the same approach in there. So this is basically just to show you how things are placed. So basic arithmetic is basic arithmetic. It follows all the conventional rules that you know, and you don't have to worry about the formalities that all the other programming languages bring to base something like dividing number or adding number and so on. Right, so this is basically all the arithmetic. I'll get rid of this. So what we've done here is we've defined some numbers, but in programming or even when you do data analysis, there's a talk about variables. We don't simply throw in numbers as in 4 or 5 or 2 or 3 within our code. We put them in a container, in a bucket called a variable. So we assign a certain number, just like these numbers we were playing with, we assign it to a variable name. And equals is an assignment operator. So when we say number underscore one equals to 100, then after that, every time we call number underscore one, 100 will be returned. So we won't have to keep typing in 100. So assign names and create variables. You must do that. You can't simply use numbers within your code unless it's a formula with some constant that you can put in. But if your values keep on changing, then you need a variable. You can't really work with values purely. Use a single equal sign to assign labels to a variable. 100, number one equals to 100, and so on. So let's see a few examples of that. Let's say create variable a and assign some value to it. So I'll create a variable a and assign a value to it, let's say 20. Now, if I run it, remember, I'm not printing everything. So now we have a variable called a with a value 20 in it. If we want to see the value of a, we can simply do print a, and a will be printed. And in Python, if it's just a simple print command, you don't even have to do print a, you just type a. Well, let's just do it in the next cell. You type a every time after declaring a variable, and it will return you 20. So now within your system memory, there's a variable a with a certain value in it. So you can keep forgetting about that value because that value can keep changing. You may perform some sort of calculations and the value of a gets updated. But all you need to remember is you call that a, and every time you call a, it returns. And once you have created these variables, you can simply use arithmetic using this variable name. So you can do a plus a now, and hopefully that should return 40. You can do a minus 10, and that will return 10, and so on. Also, you can assign new values to a. So we had a equals 20. If I reassign some value to a, now I say a equals 30, right? And now if I check a, you'll see a is 30. So you can rewrite, reassign. I mean, I've got it here. I should have written it there, but right, so this is your reassignment. You can carry on reassigning value as long as you know the variable name, you do some computation, you calculate a new value, and you reassign it to your existing variable, and that works fine. So this is how variable assignment works in the case of numbers. A variable name equals to some value. And then you can play with that variable in any way you want, and that value will be actually in play. You can reassign some value to the existing value, the previous value will be overwritten, and you will have a new value of a in there. Okay, so that takes care of it. I mean, if I print a now, you see a is 30. There are some conventions while defining these variable names. Names cannot start with a number. I mean, when it says names, it means variable names. So this is another cell. I mean, it's a text cell, which I said if I double click it, so you can see that is the actual code, which when I executed it, generates this nice list. Names cannot start with a number. So if I do 1a equals 45, right? You see invalid syntax because a variable name cannot start with a number. It has to be, I mean, if I do a1, it will be fine, right? I'm sorry, a145. So that doesn't throw an error. So that means, so that's the first convention in Python. Maybe in some other languages you can do that, but not in Python. Names cannot start with numbers. There can be no spaces in the name. And if you have to use some phrase, you can use underscore instead. So if I do variable, a variable equals 45, you can see the syntax error away. However, if I do an a underscore variable, that's fine. That's something you can do. So no first number, no spaces in between. Can't use any of these symbols, these special characters, which are basically on top of your numeric characters on your keyboard, and you do them with the shift. You can't use these within your variable names. It's a good practice. It's although it's not mandatory. PEP 8 are programming practices, best practices. I mean, everything comes with a set of best practices. Python programming comes with a set of best practices for writing Python code. That's called a PEP 8. You can read about it on internet, and that defines that all names should be kept lowercase. So A is lowercase, but even if I do an uppercase, it'll work fine. It won't throw an error, but it's not a convention. So if you write some code and send it to some other person to actually modify the code, if you're using uppercase, that may confuse, because using first uppercase means it may be an object or a class. So that's just creating confusion. In order to avoid those confusion, as long as it's a lowercase, doesn't start with a number, it can be as long as you want. You should give it some meaningful name and so on. So this is a perfectly good variable name. But the drawback would be it's too long. If you're using that variable again and again, that you'll have to keep on writing lowercase underscore variable underscore name, which is not very efficient. So just give it a small name, but it should be explanatory and following these conventions. Avoid using the characters which could be confusing, like a lowercase l. This could be easily read as 1. O, uh, which could be easily read as 0, or I, because these can create confusion. So these are just naming conventions. I mean, even if you do these, apart from these two, your variable will still work fine, but it may create confusion maybe for yourself later on or for someone else who's actually looking at the code. Also, avoid using words that have special meaning in Python. So for example, list is a data type in Python. If I try to do a list equals 45, it has created a list, but it's not really. I mean, if I so I'm zooming out. Right. So I've created a list. I've equated it to 45, and now the list tells me that it is 45. But list is a data type within Python. Now, if you're actually using lists within your code, and then you're using the same things again, we will talk about lists in a bit, then that can create confusion within your code. So list, a dictionary, um, and all of the other reserved names. As you code more, you'll get to know what all of these reserved names are. String, str is basically used to represent strings within Python, so don't use that, don't use that. Don't use the word dictionary, because that is a reserved Python word. And you can see there, as soon as I've typed it in, it has made it green. However, our previous variable names were black, so that means we're doing something funny that we shouldn't be doing, because later on, if we start using lists within the same code, then there will be some confusion. So these are some naming conventions that you should stick with. Let's just get rid of that, because that's something that you shouldn't do, and so on. So keep an eye on mine, and this basically comes with practice. As you create more and more variables, you write more and more code. Every time you do something wrong, you will see an error message, and try not to ignore those error messages. Try to have a look at them and see what you've done wrong so you can fix those as well. So looking at what we've done, we can see a simple example. Let's just create a simple formula. Where what you're doing is use object names. A variable is an object. Keep in mind, when I use term object, everything in Python is an object. So when we created a equals 20, a is an object. When we create b equals to some text, B becomes a text type of object, A becomes a number type of object, and so on. We'll talk about text in a bit, so I'll just take it down from here. So everything that you create in Python, Python actually mainly works with objects and then methods associated with those objects to keep track of computation. So use meaningful variable names, so then you can keep a track of whatever's happening within the computer. So let's say I'll say my income equals 1,000, whatever rupees or dollars or pounds. And then there is a tax rate, which is, I don't know, 0.1%. And then if I want to calculate taxes, total tax that I need to pay, I can simply do my income times tax rate. Now, another good trick that will speed up your coding is once you've defined something. So I'll just write this again from here. I've defined two variables, my income and tax rate. For faster programming, now as soon as I type my and hit tab, it'll bring income by itself. And then I multiply it by tax and hit tab, it'll show me rate itself. So that speeds up. So if you're processing tons of variables and you don't want to keep on typing their name over and over again, what you can simply do is use the tab space where you can. So I've calculated total text. Once I run it, there it's perfectly fine, but we're not giving any output back to the user. So in order to do that, what we need to do is we need to print total tab text, and that gives me, yeah, so there you go. I need to pay $100 or pounds or dollars or rupees or whatever, really. So this is basically just a simple formula, but that shows you how variables are used within code. So you assign a certain value to a variable, and then you simply work with those variables. You can create really complex formulas simply using those variable names that you actually. So, I mean, think about it in terms of your data sets. You can save, I mean, we won't be doing that today, but you can save a whole vector or a whole column or whole variable within a single variable name. And then in order to process that whole column, you simply use that variable name. You can take the mean of it, you can normalize it, you can do all the stuff that you do for pre-processing your data and cleaning your data and so on. So make a meaningful variable name. The takeaway from that is make a meaningful variable name. Make sure you follow the conventions. And once you've done that, so my income is meaningful. I could say, I mean, I could do the same thing as A equals 1,000, B equals 0.1, C equals A times B, and then just print C. So that gives you the same result, but the readability in this code, I mean, you can clearly say, you don't need to explain this to anyone. You can simply send this block of code to anyone, and if they have even a tiny bit of intelligence, they can look at it. Even I believe a 8-year-old can look at it and make sense of what's happening here. But if you're doing something like this and people, in order to just do things quicker, they'll just put A, B, C, D as variable names. And then later on, as your code gets more and more complex, you lose a track of what's happening. So this makes sense. This is, let me just add note on that, what not to do, right? So you shouldn't be doing that kind of stuff. It may be fine for you. Maybe it'll make sense for a bit, but it's not maintainable or scalable in a way. So these are numbers. So what we've done so far is we looked at how Python processes numbers, just like you would do on a calculator, how Python assigns values to variables, and what can and can't be a variable name, and what are some good practices in defining those variable names. And we've come up to this point here. This is what not to do. This is making sense. So numbers is one thing, and I told you another thing that I can add to this is when we talked about numbers, I can add a few cells here. So when I do A equals 10 and B equals 12.5. So I've got these two variables now. I did not define, because we mentioned integers and floating point numbers, I didn't have to define that A should be an integer type variable and B should be a floating point number. But if I look at the type of these, there's a command in Python. If you ever want to see the type of a certain variable, if I do a type A, it tells you it's an int, which stands for an integer. And if I do a type B, that tells you it's a float, which is a floating point number. But we did not have to define this as an integer, as a floating point number. Compare this to Java or C++, and that is to do with dynamic typing that I highlighted earlier on. Remember, keep in mind, I'm not teaching you how to code. I'm not teaching you how to run experiments in Python at this stage. I'm just sort of helping you develop an intuition around Python, why Python is the way to go forward. So this dynamic typing takes up takes away a lot of cognitive load from researchers or experimenters' mind, because then you have to public, private, and float. You don't have to worry about all of that. But it's happening in the background. If you ever want to check, this is the way to do. You can do type A, you can do type A, and you'll see both of those types. B is a float, A is an int. That makes sense. And then you do all of that. Right, so hopefully that should make sense. It's very straightforward. The second most common data type that you would use within Python are string values. String values are normally used in Python to record text information. So this word string is used interchangeably with text. So every time you see that the input is string type, so that means the input is of type text. Names, addresses, email addresses, all of that kind of stuff that goes as a string. And these could be alphanumeric characters. They could have a mix of alphabets and numbers and so on. So we'll see a few examples. Strings in Python are actually treated as something called a sequence. Let's just do a bold in sequence. I'm also highlighting some of the features of this Jupyter notebook. I'm sure some of you may be teaching after your PhDs or during your PhDs. This is an excellent teaching tool if you ever want to teach Python, and this works with some other programming languages as well. And I've just made it bold. Right, so you can do basic text formatting for your students within that, and you can bring in, you can throw in. This picture that I showed you here, I did not have to download it. I did not have to save it on my computer and then add to this notebook. All I've done is I've found a nice picture on internet on this address, and using this simple command, I've pulled that into my notebook. So it's not locally saved. It's saved actually on a website somewhere. So it's a very nifty tool. If you don't use it, if you teach coding in any way, especially Python, then this is the way to go forward. So strings in Python is actually a sequence of characters. So think about it, a string, your name is a sequence of characters. My name, Shakeel, Shakeel, is simply a sequence of characters, which basically means Python keeps track of every element in the string as a sequence. So Python does not see my name as string as one string called Shakeel. It sees it as a sequence of Shakeel, and that's why a string is a sequence in Python. For example, Python understands the string hello to be a sequence of letters in a specific order. It does not understand hello as you and I understand hello. It's not a single object for Python. It's a single object, but the single object is created out of a sequence of different objects, which are individual characters. This means that we will be able to use indexing to grab particular letters. So if it's a sequence of objects, so I mean, if I just, I think I've got an example down. Oh, there you go. I've got hello here. So hello, if you think about it, this word hello is actually a sequence of HELLO. And once we got this string, that means we can index every value of that string. So this is forward indexing. It always starts, and you must have heard about it in most of the programming language. The sequence always starts with a 0. So 0th element is actually the first element. first element is actually the second element, and so on. So hello has the five characters here, but we only got 0, 1, 2, 3. It goes all the way up to 4. So 4 means we're trying to point towards the fifth character. And Python adds something to that. This is pretty much something you'll find in any programming language. Python adds something on top of that. You can do reverse indexing. So if you want to get the last character of any string, you do a -1. -1 always refers to the last character. -2 is second to last. -3 is third to last, fourth to last, fifth to last, and so on. So let's just see a few quick examples of that. What exactly do we mean by that? And hopefully that will make a lot more sense. Sorry. So let's say a single word. So an enter in a Jupyter notebook is next line. A shift enter is next cell. So I accidentally keep pressing the shift enter. That's why I go to the next cell. Just like that, I can print a string hello, and that string will be given in the output hello. And there's no way to save the string because we are not saving it in a variable. So just like that, this is a string. Let me add a few cells there. This is also a string, right? So string could be a combination of any number of characters with spaces in between. So this may look like a sentence to you, but it is once again a sequence of characters with a character which is a blank space character in between a group of sequences, and that makes a sentence. And that is a sentence. One thing you can do in Python is you can use strings with single quotes, and wherever it's a general convention in Python, because normally in other programming languages you will have to use double quotes for strings. That works fine in Python, as well as what we did earlier on. This works fine in Python as well. So single quotes or double quotes, they both work fine. But what you cannot do is start something with a single quote and end with a double quote, because as soon as you do that, you'll see an error. End of line while scanning string literal. So it's basically expecting an end of line how we started the line with a single quote, but we didn't provide that. Instead, we provided a double quote, which confused Python. So you shouldn't do that. This is a string, and this is also a string, as long as there are same conventions followed. Okay, just like that, a variable name, I can define a variable my name equals Shaquille. Right, so this is assigning strings to variables. So my name is Shaquille, that's it. So every time after this, I want to get my name back, I'll just simply type my name, and that will return Shaquille. Right, so let's just do a few basic string operations. Now, every object in Python, so we talked about number being an object, we talked about string being an object. Every object which is built into Python comes with a bunch of methods that you can apply onto that object. You don't have to define those methods. Those are there. You can simply call them. For example, there's a method. I showed you one built-in method, which was the type method there. Type method will take in an object and return its type. What type of object is that? So down here, if I do a type my name, so here, now I've pressed the tab as I explained before, but there are now two variables within our environment starting with my. So my income, which I defined earlier, and my name, which I'm defining here. So when I hit tab, I'll see two options, whether I want to use my income here or my name, or you can have 10 more variables starting with my. I can use my cursor keys to select the one I want. So I want to see the type of my name, and that tells me my name is of string type. So just like that, For any collection, string is a collection. We'll talk a bit more about other collections. You can check the length of a collection, how many actual individual characters are within that object. So if I check the length of my name, it'll return 7. There are 7 characters in my name. So len, which stands for length, I'll make a note of it. Right, so I'll share these notebooks with you later on, so you can just follow these, and it's a good idea to make some notes. Length of n of a sequence. So not only strings, but any type of sequence. There are other sequence types within Python that work fine here. Right, so I think I made some notes here, but I've been doing all that stuff here. Printing the string is just like printing a number. You just need the name of that string and I'll return it. You can simply call it and it'll return it, or you can use the print command, which is the good practice for that, and so on. I think I've done most of the stuff up there, which I wanted to do here, so I'll just get rid of it. And the thing that we need to learn about string is there are tons of methods. What you can do is, let me just open a new tab. And search for Python string methods. So there's so much help information about all of these topics. However, I'm just trying to summarize it as much as I can. That's why it may seem like I'm rushing through stuff, because I just want to highlight the key topics, which you can then later on just do a simple. So what methods can we apply on strings? W3 School is an excellent resource. I mean, I remember like 20 years ago when I started learning web development, not even 20, 25 years ago. This website has been around since then, and they've got excellent tutorials for everything. Right. So these are some of the methods that you can apply on strings. Capitalize them, case fold them, center, count the letters of a string, encode them into some other form of encoding. You can check if a string ends with a certain character. You can find a certain pattern within a string. And there's a lot that goes in there. I mean, I can't really cover all of these, but every object in Python has a bunch of methods that go within that. So these are the string methods. You'll find them on tons of websites, W3 schools, or you can actually go to Python's official documentation. It won't be as detailed, but it summarizes everything. So these are all the string methods thrown at you. I mean, if you know what you're trying to do, then you can just pick up a method from there. Just like string have methods, Python numbers have methods as well that you can simply apply on them. Well, those come under casting and so on, type conversion. You can change an integer and use the float method to convert that into a float and take a float and so on. You can change the type, you can check the type and so on. So all of these methods, this is just a matter of exploring all of these methods, because I mean, you can't really go through each one of them one by one, but just the idea, it's always with the notation object.method, and we'll see a bit more about that. Let's just focus on string indexing for now. And we see a string here, hello, and I highlighted that every single element of the string is indexed. And there's an index value to call every single element of this. Let's see, let's just define a string, same string or any other string. We call assign a value to assign a string value to a variable, right? So you won't have to type simple commands like that every time. So I'm just leaving it in for your reference later on. Let's say a string called s, and I'll call it hello world, right? So that's the first thing that you do every time you're learning a programming language. You try to print hello world on the screen. Right, so that is saved. We haven't printed it, so it won't come out. If we want to see what's in there, we can either do S or print S, and it'll show us that it's hello world in there. Now let's see how indexing works. So, I mean, we talked about hello. Now we got hello world. Hello had 5 elements in there. Hello world is 6, 7, 8, 9, 10, 11 in there. So if I want to access the first element of this collection, I can do S, which is the name of that string, and within parentheses, sorry, square brackets, I can type in the index value that I want to extract from here. So if I do S0, it will return an H, because 0 is the first element, and same here, 0 is the first element of that string. If I do S1, just like then, HE, and so on. If I want to get the last element, what was it, 7? If I do 9, is L from the world, so the 10 would be the last one, D. But if I do 11 now, let's see what happens. Any guesses? String index out of range. So our range was from 0 to 10 for these 11 characters. But when I put 11, that means I'm trying to point towards the 12th character over there, which doesn't even exist. So that's why you get an error. So this is how you basically index stuff.
What about the sixth one? Like, for example, hello 1, 2, 3, 4, 5, but the sixth one is a space. For
Yeah, so you get a
example,
space. So let's say if I do a 0, 1, 2, 3, 4, 5, you get an empty space with, I mean, everything is a string, so you get an empty space, but it's shown to you as a string. There's nothing in there. If you do a 4, you go to O.
so it means the space is also an index number.
Yes, space is a number. I mean, space is an element. You won't call it a number. It's a string element. And you can have a string, let's say, now that you've highlighted it, I can have a string which looks something like, right? So I don't know how many times I've done that, but that's a string as well. If I print it, it'll print that string. If I want to point towards the first element of that string, it's a blank. If I want to point out towards the fifth element of, so blank space, I mean, we see it as nothing, but it's actually a character, and we can have a combination of that character over there. So that's perfectly fine. You could do that. So blank space would be considered as an element, as the 2, 3, 4, 5, sixth element of this string. Yep, that's an excellent question. Also,